Hey, hi Pratik. Good afternoon. Thanks for joining.
Yeah, Ajit, good afternoon. Yeah, thank you for giving me this opportunity.
Yeah. So maybe we can get started with a quick round of introduction. Then maybe we can deep dive further in the questions.
Sure. So I'll start with the intro first. So I am started my journey as a cloud engineer, I think 5.5 years back. In that process, I started with development and I did it for like a couple of months. And then I slowly moved to the deployment part of it. I started liking creating infrastructures, automating them, creating CI/CD pipelines, and automating things in Python, Shell, and whatever way it is possible because making things easier was one of the thing that I loving about it. And then I moved to a different organization where I worked as a solutions engineer. So understanding customer problems, like suggesting them a good architectural overview and how they can make or use the product in a better way. And after that, I moved to a different organization where I worked as a senior DevOps engineer. And my entire responsibility was to automate the things and make processes easier, how we can roll out the updates frequently without any interruption, and making sure the reliability and high availability as well. After that, in my current organization, I'm working as a consultant, and I've worked with different engagements across teams. Um, and Yeah, so it's mostly about the DevOps best practices and automating things.
Yeah. So thank you, Pratik, for your brief introduction. So to start with, consider that you want to develop a e-commerce application uh, that will be accessible throughout the world. Okay, so it is a international application. The requirement is it should be highly scalable, robust, and it should be highly available. Okay, so you are free to use all the AWS services which you like. Uh, yeah, so the requirement is simple. It should be highly scalable, it should be reliable, and it should be highly available. Yeah.
Okay, sure. So I'll start with the networking part of it. So we will be using a VPC and a subnet. So I think there should be at least 6 subnets. So two for web layer, two for app layer, and two for database layer. If the database is resides in a VPC like RDS or document DB, and in those private subnets, we will be having our application servers in the app subnets, and then in database subnets, we will be having our databases like RDS. It could be MySQL, it could be Aurora or Postgres, or it could be document DB cluster as well. And we will also be having NAT gateway as well as internet gateway for our VPC, and then we will be having transit gateway as well if you want to access data from our data center, which resides in the organization or somewhere else as a local. And then we will be using load balancers for equally distributing the traffic across our different instances. We will also be implementing auto scaling to make sure we can cover the load and increase the number of servers whenever there is a high traffic coming in. We will be utilizing AWS RDS for structured databases, which supports Oracle, PostgreSQL, MySQL, MS SQL, etc. And we will also be using DynamoDB if we want to use NoSQL database. We can also utilize DocumentDB. And so networking, we are good. Database, we are good. For storage, we will be using S3. So for storing any object wide data, we can use S3, and we can also use S3 for hosting our static content. And over that, we will be utilizing CloudFront to as a CDN to deliver that content faster with a low latency. For DNS management, Route 53 is there, and for so network is done, storage is done, database is done, and I think compute. Yeah, for compute, we can utilize the EKS clusters to host the backend, and ECS as well. It is based on how we are architecting our application, and if it is monolith, we can also go with the EC2 instances. And AWS Lambda is one of the things that we can go if we are using serverless. So I think this is a very high level architecture that we can create for an e-commerce application.
Okay, perfect. So you mentioned monolith and microservices in your answer, right? So you mentioned EKS, ECS, and normal EC2 instance-based monolith. So
Mhm.
under what circumstances or under what requirements you will choose either monolith or microservices, and which is more beneficial against each other?
Yeah, it depends. If we are just starting with our product and we don't have the expertise or the affordability, I'll say, to have so much of resources that will learn Kubernetes, that will manage those clusters, because EKS, you have to manage the clusters, you have to manage the EKS versions, you have to learn how to implement all those things, and it could be a bit difficult. But like if you have a if you are having a startup and if you just want to get started without all those hurdles, then you can just start with a monolith application. And also, if your architecture does not require to be that complex, then it's better to go with monolith. But if you want flexibility and much configuration management and all, then it's better to go with the container based system like EKS or ECS.
Okay, so what is more complicated according to you? Is it Kubernetes-based systems or maybe monolith? So if you have a large teams, okay, say let's say 10 or 12 developers and DevOps engineers working on your product, so which one will you choose? Will you choose monolith or microservices or maybe EKS?
Yeah. It will majorly again depend on the architecture of the application. So let's say if it is having like 70 to 80 services, so I need to manage like routes for all those, and also like the backend of all those applications. So it's easier for me as a DevOps to manage all this via a Kubernetes-based systems, because I don't want to manage all those routes in a monolith system where I have to create the routes for all those. So let's say if I use Nginx, I need to create all those routes for Nginx, then it will pass to an ALB and then eventually an EC2 or something. But if it is EKS, I can have a service created for this. We can easily automate it, though it is manageable in monolith as well. But like having a Kubernetes-based architecture, make sure that our application is reliably running, because whenever it goes up, like EKS will automatically keep it running. It will alert us. Like monolith also does that, but EKS makes it easier for us because it is managed.
Okay. Yeah. So, and in case of monitoring or maybe observability, how would you monitor this entire ecosystem or maybe entire application? So, what kind of services will you use? Will you use all the AWS services or maybe some external help as well?
Mm. Yeah, so when it comes to monitoring, we have very good tools available outside of AWS. So I'll go with Datadog and Grafana for the visibility, because Datadog also provides all the infra level loggings, like what request we are getting, and what is the latency time, and if there is any error, if there is any warning. So all the traces related to the application infra. AWS X-Ray is one of the services within AWS that I'll go with for application level insights. If there is any application bottlenecks with an API or something, if you want a very simple architecture, then it is AWS CloudWatch, because it also has a lot of log insights within it. So every service has a log stream created if we want to get it correctly.
Okay. So, if CloudWatch and X-Ray has all the required features, then why exactly you would require Datadog in the first place?
Yeah, so it totally depends on our requirement. CloudWatch does provide a lot of features, but when it comes to configuration, so let's say if I want these much applications in a group, this much projects in a group, if I want to make sure that these much parameters or matrices outside of the supportability of CloudWatch, then I can go for those custom metrics with the open source tool rather than AWS managed, because there are certain limitation when it comes to configuring CloudWatch. So we can't like go out of those limitations. So for that purpose, we can use some open source tools as well.
Okay. So, in case of a disaster, okay, so just in case, as I mentioned in the beginning, so it is a multi-region kind of or a maybe international application. Just in case any region goes down, or I mean maybe any availability zone goes down in your system. So how would you react, or how would you build systems, or maybe how would you automate stuff so that your application is not impacted at all?
Yeah, so for disaster recovery purposes, we have to make sure that our core database, where our data is residing, is replicated not just across AZ, but across region as well. So although we will be having multi-AZ configuration for our production deployment, we need to make sure that we are having a copy of it across region as well. So we need to configure the cross region replica of the RDS snapshots, which should be synchronous, of course, so we don't lose any data. And for like storage, whatever storage that we have in our S3 bucket, we need to set up a cross-region replication for that S3 bucket as well. And if required, we can also use like a global load balancer, which will make sure that if a region goes down and it is not serving, then we can utilize the data that is available within the next available region. And for DynamoDB, as a global table is a thing that we can make use of for those kind of disasters. So yeah, these are some of the high level things that I'll implement whenever designing an architecture.
Okay. So we spoke about observability, we spoke about fault tolerance and DR. So if we want to secure this particular application, okay, if you want to secure this application as well as the cloud infrastructure, so what best practices or what measures you will take so that your application becomes secure?
So when it comes to security of the application, so first thing as an e-commerce application, that the threat it gets is like DDoS attack. So we need to implement a AWS Shield, which is a managed AWS service, which will make sure that whenever there is a traffic that is not expected and it is not legal traffic, I'll say, so it blocks it to a certain level, so it does not impact the running application. And we can also implement AWS Web, which is like Web Application Firewall, which makes sure that our application level application related threads are managed properly. And whenever there is a compromise to the security, we'll make sure that we are securing that application using rules in that web. And when it comes to like accessing services within AWS, then in that case, we can use IAM roles for the least privileged accesses. So like if EKS wants to access DynamoDB or RDS, it is only utilizing the data it's need to and not more than that.
Okay, great. So moving on to the cost optimization section. So the customer is quite cost sensitive, okay, and as we are using a lot of AWS services, right? So AWS is not cheap, right? It is going to incur a lot of costs, right? So with respect to your observability, security, and DR. So what cost optimization measures you will take so that it does not affect the customer intake, so in terms of taking a decision whether to choose this particular service or not? So basically any 5 key points that you will implement in your systems so that we are also kind of making sure there are no humongous costs.
Okay, so cost optimization as in like entire application or only within the storage part?
It can be generic to AWS. So it can be within all the services. It can be with EC2 instances. It can be with S3 buckets. It can be with RDS instances. Anything that comes to your mind, it is okay for me.
Sure. So I'll start with the compute part. So when it comes to like having the instances, so we need to make sure what our application actually requires, whether it will be memory intensive, like compute instance intensive, or like GPU intensive. Based on that, we need to select the right instance type for that. And we also need to make sure that we are having a reserved instances plans as well, because if we are sure that we will be using these many instances for these many months or years, then it's better to go with the reserved instances policies, which gives us a discount up to like 70 to 80% and saves us a lot of money. And we can also use the spot instances, which are cheaper, even though we are not sure when those instances can be taken back. But it is better to go with the spot instances for any non-prod use cases, and for stateless application where we don't really need the reliability for the instances to run continuously. And for storage, like within S3, we can have the right S3 storage classes. So for frequently accessed data, we can go with the S3 standard one, and for infrequent one, we can have the AI IEA configured. And then for like the archives and as well, we don't want the storage to be standard, but we can use the S3 Glacier. And when it comes to like file system storage, like EBS, then we need to make sure that we are selecting the right EBS type. So there are like GP2, GP3, IO1, all those available, but we need to make sure that we are selecting which like serves the purpose of that particular like EBS type, and we should not be using like IOPS based highly IOPS based EBS volume if it is not required. And so yeah, and when it comes to like a data transfer cost within AWS, we need to make sure we are using like VPC endpoints for private connectivity to avoid data transfer charges, because like NAT gateway costs a lot. So and so we need to make sure when we are transferring the data within availability zones or within the regions, then these costs are taken care of. And for RDS, we can use the RDS reserve instances, same as the EC2s. And for like for CI/CD and all, like when we use like code build or code pipeline, so we can also optimize those builds or tweak those configurations to build it faster by having like stage build and like using an Alpine image or something. So these are the like some of the things that I look into.
So one final question on this particular use case. So since this is a big enterprise, right? It is an enterprise like Amazon or Flipkart. So they have certain on-premises systems as well. Okay. So they want access to the e-commerce applications, servers, databases from their on-prem systems. So what kind of services or what kind of systems would you use so that you have established the connectivity between your on-premises and your e-commerce application that is residing in AWS?
So there are several ways to achieve that. One thing is we can have a site-to-site VPN connectivity within AWS. So there will be a customer gateway, and then there will be an AWS gateway, which can have the connectivity. So it will be over the internet, of course, but it will be a private connectivity one. Not we are not directly targeting the EC2 instance to connect to it. And one more thing that we can do is like make use of direct connect, which is like physical lines or physical cables, which connects your data center to AWS data center or availability zone. So that is very much faster and safer, but it costs a lot. But if we have a lot of data to be transferred from your data center to the availability zones, or if we have a lot of data to manage on the flow, then it's better to have a direct connection between them, because in longer term it will save us the cost.
Okay. Yeah, so Pratik, that was it for the AWS thing. So moving on to Kubernetes and EKS, what exactly is a stateful set and how it is different from a deployment?
Yeah. So stateful set is something that is like so let's say if I'm having so many pods for a service. So in stateful sets, it will make sure that there is a dependency between the pods. So even the provisioning of the pods will be sequential. It won't be like all pods are coming up together and then like shutting down together. So there is a sequence that it follows, even for the rollbacks and updates as well, to make the scaling efficiently. But in case of a deployment, like all the pods are stateless, so there is no dependency between them. And let's say if and they don't have a unique identity to be clear, and they are treated the same way. If one is replaced, the new pod will not be able to like distinguish which one was down. But in case of stateful set, the pod have a unique identity, and they're assigned an ordinal index as well. So even that identity persists even if the pod is rescheduled. So this is important for application that needs to like maintain state across pod restarts. When it comes to storage, deployment typically has stateless storage. So it means like data is not preserved when the pod is deleted. So if persistent storage is needed, it has to be manually managed or associated with a pod. So it doesn't require unique persistent per pod. But in a stateful set, like each pod can be associated with a unique persistent volume. This ensures that the pod data is preserved across restarts or rescheduling, which makes it ideal for stateful applications where data persistent is crucial.
Okay, any example that comes to your mind where you have utilized stateful applications or maybe stateful sets?
Yeah. Let's say if I have to manage a database, or if I have to have a database in a cluster. So for that purpose, it's better to go with the stateful set because it is persistent. It has a volume. It won't be like killed and my data will be gone. But if I want to have a stateless application, which is just like getting a request and then delivering the data after fetching it from database, then if that service, even if it restarts, it will not lose any data. It will not lose any state or something. So in that particular case, I'll go with the deployment for a service which is serving data from here to there, and for a database kind of a thing, I'll go with stateful set.
Sure, Pratik. So how do you create a multi-stage Docker build?
Yeah. A multi-stage build in Docker like allows us to use multiple from statements in a single Docker file, basically. Each has a separate build stage, and this becomes very useful when we have to create smaller and more efficient images by allowing us to like copy only the necessary artifacts from one stage, and it will remove everything else which is like not required. So the major things of this functionality or technique is each from statement like starts a new build stage, and we can have as many stage as we want. Like each stage will use a different base image. And artifact copying, we can just copy the artifact from one stage to another using the copy statement. So we can just write like copy from this stage, and then whatever stage we want to copy it to. And this approach is especially useful to build like complex to have complex build process where the build environment is different from the runtime environment. So let's say I'll have an example of a multi-stage build where we are building the application for Golang. So we can write like from Golang some version, and then we will be setting up the working directory, and then we'll be copying the module manifests from with the copy command. So copy go something and go something, and then slash and we will also download the go module. And now we want to like build the application. So what we will be doing is like run a go build command. It will build the application, and now we create a minimal runtime image. So how we can create that is we can just set the work. We can just use a from statement and use an alpine image and set the working directory with a work dir command, and then we can copy the previously created build from the previous stage to this particular stage, and then we can just run the commands. So what are the benefits of this is like multi-stage builds helps us to create optimized Docker images by making sure it separate out the build environment from the runtime environment, and it minimizes the final image size. And this becomes useful for production environment where a smaller image size are preferred for faster deployment and like a reduced attack surface.
All right. So as we know that Kubernetes is quite complex, right? So it is not easy, and it is not for beginners, certainly. So what kind of troubleshooting scenarios you have faced in your current project or maybe in production systems that you would like to highlight to me?
So there are several errors that we face while maintaining our clusters. So one common error is crash loop backoff error. where the pod goes in the pending state due to some issues. So it could be due to like it is not able to fetch the image, or it is not able to start the application. So we can run the get events command and get the events of that pod, and we can also describe pod if there is any misconfiguration that needs to be taken care of. But the get events give us a good idea of what is happening and what has caused the failure. But another issue could be you're not able to like fetch the secrets due to some permission issues. So we need to sort it out as well. One more major issue that we face is Node is not having the enough resources to I'll say scale the pods. So we have to like add on the nodes as well. So even though it is auto scalable, sometimes there are chances that it is not able to scale beyond the max capacity that we set. So in those cases, we need to like manually increase the node count. So yeah, these are some of the issues that we face.
All right, all right. So in microservices world, there would be n number of pods, right? So there would be thousands of pods, okay? And it is not possible to a human to log into each and every pod and get logs out of any particular pod. So what kind of login mechanism you have implemented in your EKS cluster or in your Kubernetes cluster so that the log files or the logs are centrally accessible to each and every developer or DevOps engineer? So have you worked on a centralized logging kind of a solution?
Sure. So to answer that, we have implemented Datadog agent for all the services. So it acts as a daemon set in every node. So since it is a daemon set, it runs in all the nodes and get data for all the services, and we can see which services are having errors, if there are any warnings or info in the Datadog console only. So when we go to the application insights, we see all the data related to how the application is performing, if there are any errors that is coming in. So yeah, to answer your question, we are using Datadog for that. And to see the logs for our local, let's say if you don't want to go to Datadog, and to like manage our cluster. So we are using Lens for that.
All right, all right. So I see a lot of GitOps and Argo CD in your CV. So what exactly is GitOps and Argo CD and how it is different from traditional CI/CD pipelines or traditional DevOps setup?
Yeah, so GitOps is a very well-known thing now in DevOps world. In this, our source of truth relies in the Git repository. So whenever we push or merge changes to Git repository, it acts as a source of truth. So whatever changes that we have merged will get build it, like test it, and whatever steps that we want to do, and then further it will be ready for the deployment. So for like the deployment, we used Argo CD, which was responsible for deployments within a Kubernetes cluster. So whether it be a service and deployment, stateful sets, secrets, configs, everything was managed by Argo CD. And it was very easier for us to like have a good flow of how our application is updating, what services, what pods, what kind of update strategies there, what kind of rolling back strategies there. So Argo CD was easier for us to manage. So the pipeline was in GitHub Actions, where we built it, tested, and done the steps. And Argo CD was something that we finally deployed those artifacts to. And then it was then deployed by Argo CD to EKS cluster.
Okay, so you mentioned about deployment strategies, like, so what kind of deployment strategies are there in Kubernetes, or how many types maybe you can implement?
There are several deployment strategies. The very famous one is like a blue-green deployment, where we have an entire set of application ready to be served side by side, and we try and test that particular say. So we can say like if we are having V1 and if we want the V2 to be deployed, then we make the entire infra ready for serving, and then we test it. If that works well, we shift the traffic from V1 to V2. And another one is ruling update, where we define the strategy for the pods to update incrementally. So it will replace old pods with the new ones, few at a time. So it will not be like all the pods are going down and then all the new pods are coming up. So it will like try to shut the old pods down one by one and like make the new one coming. Application has multiple version running simultaneously, and this is good for like production use cases where uptime is crucial, and it has allows for gradual replacement, which can be monitored for issues. So let's say my old version was running seamlessly and my new version is having some issues, then I'll get the errors. I can see those and I can stop that and roll it back, instead of like having all the pods updating at the same time and then getting surprises. And so I mentioned blue green, I mentioned rolling, and one is like canary deployment as well. In canary deployment, it releases the new version to a very small subset of users first. So let's say 5 or 10% of traffic, which allows the testing in production before gradually rolling it out for the entire user base. How it helps is it minimizes the downtime to nearly zero, because the traffic is split between the old and the new version. So it is ideal for testing new feature in production with very minimal risk. And if the canary version works well as expected, then it can be gradually rolled out to the entire user base.
Okay, yeah, great. So consider that you have deployed an application in EKS. Okay, so this application requires access to DynamoDB tables and your S3 buckets. Okay, so to give you a scenario, so your pods will require access to your S3 objects, and they will also require access to the DynamoDB tables. Okay, and I should not configure any access key and secret key within the application. So that is one use case or maybe one requirement. So how will you ensure that this requirement is fulfilled?
Sure. So for that purpose, we can create an IAM role for service account, which is called as IRSA. And to securely grant like EKS pods access to AWS services, like you mentioned, S3 or DynamoDB, we can make use of IAM roles, which we can assign. So we can assign AWS permission to Kubernetes services accounts, which can be ultimately utilized by the pods. So we can have an IAM policy created where we will be mentioning the S3 buckets, DynamoDB tables, and what kind of access we want, like put table, put item, or like get bucket, put item, get bucket, get items, and all. And once we create the IAM role and policy, we need to create a service account in Kubernetes. And within the service account, we can mention the IAM rule that we are about to assume, and we can also mention the role in all. And then after that, we can just use those services, and it will in our pod configuration, we can mention the service account, then it will which will be utilized to access those services, and we are good to.
All right, all right. So if you have to develop an application and deploy that application across your Kubernetes clusters, so what would you prefer? Would you prefer deploying using a Helm chart or maybe a traditional Kubernetes manifest file? So which is easier, and what would you choose?
Yeah. So it depends if our application is very big and have a lot of services, deployments, and config maps. Then it's better to go with Helm charts, because these are the templates within the Kubernetes manifest. So it instead of like managing multiple YAML files manually, we can make use of Helm charts that package together all the necessary resources. And Helm chart also simplify the maintenance by allowing us to use variables and templating. So we can define all the values in values.yaml and use it across our manifest, and which becomes useful while managing multiple environments. So we can just change the values and we are good with it. And when it comes to like traditional manifest, so whenever the number of resources grows, so we need to make sure to manage those files properly, because like we have the repetitive configuration which can change across environment. So it involves a lot of writing and maintaining separate YAMLs for each Kubernetes resource.
Right, right. So the Kubernetes part or EKS part is done. So let's move to Terraform. So consider a multi-account structure in AWS, or maybe an organization or a landing zone kind of a setup where we have multiple accounts. So we have log archive account, we have security account, we have networking account, and then we have application accounts like your production, UAT, dev. Okay, so considering these many accounts, the accounts are already created using Terraform, and we have to create infrastructure in all these accounts, and we have to deploy applications in all these accounts. So what would be your ideal Terraform directory structure to manage this entire ecosystem or to manage this entire landing zone?
Sure. So when it comes to the directory structure, it will depend on two things. One is the kind of resources I'm having. So as you mentioned, we are having separate network security and logging account, and the application accounts as well, like account A, account B, account C, and along with multiple environment. So my structure would look like uh, I will be having modules created for all those logging, security, and networking resources, which I will be reusing within the different environment. So how my structure would look like is I will be having a TF modules directory, which is root directory. In that, I will be having multiple modules. So for networking, I'll be having a module for logging, for archiving, and for other purposes, if I want to have any other AWS account. So let's say for serving or something. And then I'll have environment-based different accounts. So environment A, or let's say environment dev, environment UAT, environment prod. And in those directories of environments, I'll be having the configuration for that specific environment. So I can reuse those modules by just passing on the variables. And by reusing the modules, I mean, we will be utilizing the TF modules, directory modules, and we can just pass on the variables to that particular module and provision the infra. So same will be for UAT and prod as well. So we don't need to like write the same repetitive code of all those resources again and again. We can just reuse it in modules.
Okay, so you mentioned modules, right? So modules are also the custom modules which you develop, and there are few modules which are official modules from AWS on the Terraform site, right? So if you create your custom modules, so what benefit it gives? Because some of the modules or most of the modules are already developed by third parties, and it is certified by AWS and Terraform. So why would you create your own modules?
Yeah, so it depends on our requirement. If we want to have only certain parameters to be used, then we can have only those many parameters as inputs, or I'll say variables, which will be passed on, because it won't support the all the set of variable that is provided by AWS Terraform module, which is like official one. So if I want to have any uh, manual configuration change for that particular module, then I can write my own module, even though it will have the same resource block behind the scene and same variables and same parameters behind the scenes. But it involves rewriting the module by yourself, even though you can also use the manage AWS one and write a wrapper on top of that and reuse that.
So have you ever worked on dynamic blocks in Terraform? And if yes, what exactly is that? And what is a use case of that?
So I recently used a dynamic block while creating a DynamoDB table where I required multiple attributes to be used. So for that, I passed a map, including a lot of attributes, and which for every map value, it creates a new configuration block, and it will just iterate over that for loop. I'll not say for loop, iterate over that mapping, and it will just create all the configuration attributes, which is passed in that dynamic block.
All right. So one last question, Pratik, and then maybe we can wrap up this interview. So how would you create a perfect or a near perfect DevSecOps pipeline? So you are free to use any kind of tools. It can be open source, it can be cloud. I want to know the answer right from the developer checks in his code till the actual production deployment. So yeah.
Sure. Whenever a developer checks in his code to testing phase, so the testing tool could be SonarQube, and then there will be a security testing phase for that application. And for that, AppSpider is a good tool which provides like comprehensive security testing for web and mobile application. And after that, it will go to the container security step, where the container will be scanned for any vulnerabilities. So Aqua Security is one of the tool that I have used and which worked well. And we can also like if we are using, let's say, infrastructure as code, then we can also use TerraScan, which is a code scanner for infrastructure as code. And for secrets management within the application, we will be using AWS Secrets Manager, or let's say if it is open source, then we can use Doppler as well. Or like if we want to go ahead with the HashiCorp Vault, then it also works well. And for CI/CD tool, we can use Jenkins or GitLab CI or Circle CI or Octopus Deploy, whichever serves our purpose well. But like Jenkins is an open source, so if you just want to get started, it's a good tool with a lot of features. For runtime security and monitoring, Sysdig is one of the best tool that that I've used. And for cloud security, Prisma Cloud works well. So these are some of the tools that I'll go with.
Okay, and what would be your deployment tool? So you forgot to mention the deployment tool. So if it is a EKS based application, so how would you deploy your Docker image onto the EKS cluster?
Yeah, if it is an EKS image, I'll go with the Argo CD, which is perfect for the EKS workloads.
Okay, okay.
Sure.
Yeah, thank you so much, Pratik, for your time for this interview. I really appreciate. Thank you so much.
Thanks, Ajit, for your time. Thank you.